Good afternoon, everyone. This is Roberta Rossi, and welcome to the fourth of our webinar series in the Innovation Challenge. Happy to have you here. We are going to wait just another moment because we're waiting for a couple of more people to join us, and then we'll get started. So please bear with us, and we'll be back in a moment. Okay, folks, I think we're ready to get going. Well, welcome, everyone. As I said, I'm Roberta Rossi, and I'm the project manager for the Innovation Challenge. I also have with me Deb Santi, who is the Director of Small Business Innovations here at Connecticut Innovations, and we're very happy to have you here with us today. Today we're going to be talking with Ultra Electronics Measurement Systems, and we're very fortunate to have Monica Roy from there with us today. And we'll be chatting about display improvements to handheld devices or portable devices. She'll talk to you about the technology and what it is that they're looking for and her expectations for the challenge. And Deb and I are here to answer any questions that you may have about the process. We'll be talking about the applications in a bit. And we're really here to help you do the very best you can to get positioned to be successful at this challenge. We really do want to see you succeed. So before we start, let me just go over what the agenda will be today. I'll be giving you an overview. Monica will then be talking to you about the actual topic, and you'll have an opportunity to ask questions. Now, I do want to let you know that only the speakers will be able to be heard. So if you have questions, I need you to put them in your question box and submit them through there electronically. You can do it at any time during the presentation that you want. And we are going to batch them, and we'll answer them after the presentation. So do go ahead and send your questions in. The other thing is, if you're having any difficulty at all, please send us that as well. Let us know through your questions box that you're having a technical problem, and we will work to get that resolved for you as soon as we can. Okay? All right, let's see. I think that is it. So that being said, let's get started. I want to talk to you a little bit about the challenge itself. As you know, it was announced in November. We have $500,000 in the funding pot available for this. And the reason the challenge got started was because we are in a wonderful time of open innovation. And because of that, you have some large companies whose customers really have some critical emerging market needs. And these large companies are really looking to service these customers, but they don't have all the answers. They're looking to medium-sized and smaller companies who have some wonderful ideas bubbling that can solve these problems, but they don't always have the research and the empirical rigor behind them to validate them, to back them up, so they can get these ideas up to market. We also have some great work being done at our universities and our schools who do have the empirical research and the ability to validate these ideas so that the concepts can get to market. And you put them all together, and it's a perfect storm for a challenge like this. So we decided to put them together to solve those problems and to really expedite the timeline of concept to commercialization. So let me tell you a little bit about the challenge itself. It's a $150,000 matching program. What that means is the state will kick in $150,000. Small businesses will then have to match that. 50% of that match will need to come from cash. And if the small business can't finance that cash themselves, think about getting some investors to back you. The other 50% can come from in-kind contributions, and those are non-cash contributions like overhead, rent, perhaps consulting services, other universities that you want to pay. So 50% of that match, as I said, has to be in cash, and the other can be in-kind services. And for this particular challenge, we are requiring that a small business team up with a university to propose a solution. Not all of our programs work that way, but because we do really want to foster a collaboration between academia and industry, we've put together that requirement. So if you are a small business that needs a partner, or if you are a school that needs a partner of a small business, we'll talk in a little bit on how you can get that done. Okay, that having been said, I'm going to turn it over to Monica. She's going to talk to you about ultra-electronics measurement systems and what they're looking for in the challenge. Monica?
Good afternoon, everybody. Thank you for joining us today. And I'm Monica Roy. I'm Director of Marketing and Strategic Planning for Ultra-Electronics Measurement Systems, Inc. Ultra-Electronics is a UK-based company with approximately, at this point, I believe it's 29 individual entrepreneurial businesses, most of which are involved in markets of defense. We're also in energy, information systems, cybersecurity, and some other related markets, airport systems, for example. So, but by far, the concentration of Ultra is in aerospace and defense, and that's MSI's market concentration as well. So if you go to the next slide, I'll talk to you a little bit more about MSI specifically. What MSI does is we design, manufacture, and customize systems and controls that maintain the human in the loop. So that's a big way of saying that we make human-machine interfaces for various types of systems. Our concentration has been in hand controls. So our primary mode of interface is with the hand. And the product that most people would be familiar with is a joystick. So we make basically joysticks on steroids for military applications. So these are, I apologize for my email popping up. Close that. Sorry, I'll get back on track here. Okay, so what we tend to control are weapons and payloads. And those payloads can be anything from a sensor to a robotic arm to a weapon itself. So because of the environments that we're in and the abuse that our products see and the increased demand for reliability and safety, our products tend to be over-designed for commercial and industrial use and very specific for defense applications where the quality and ruggedization justify the prices that we have to charge. Our primary application areas, as I've got on here, are unmanned systems, and that would include unmanned aerial vehicles, unmanned ground vehicles, underwater vehicles, surface vehicles, and unattended sensors. And that's a significant growth area of development, technology development, basically across the board. And some of you may be aware that there's a FAA effort to allow the operation of unmanned aerial systems in civil airspace. So that's an ongoing effort to start expanding the use of UAVs from military and homeland security to civil use. We're in payload and weapon control, as I mentioned. Soldier systems is also another area where you're providing a system basically on the body of the soldier for them to interface with the mission systems that they're using while they're deployed on a mission. Portable battle management is a way to term how a command system would work. So maybe you've been familiar with a command center with various screens and controls and interfaces going on. This is basically taking most of that and putting it in a commander's hands. So and this would be used at the brigade or troop level. So not every soldier would necessarily have a portable battle management system, but the commander of that brigade would. We're also in space. So a lot of our application in the past has been in simulation. So that's a market, that area that we had focused on. And in a lot of respects, simulation requires even greater reliability because of the increased usage. However, our focus now is on tactical systems. Next slide. Okay, so what we're here to talk about today, though, is a growth area and a focus area for MSI. As everybody, I'm sure, is aware that everybody is asked to do more with less, especially in this economy, and that everybody's doing things on the go. So it doesn't matter if you're in defense or running a home or working in your business. All of those things are requirements, and those are now translating over to our military systems. And as such, a big significant area for us has been handheld controls. So and these controls would interface with all of the types of applications that I detailed before, although briefly. So the game style controller that you see here is our freedom of movement control unit. It's an FMCU. It's the first fully ruggedized game style controller. So this is leveraging the form factor that soldiers grew up with, and basically we focus on intuitive control. So we want people to, be able to pick up one of our controls and be able to figure it out really quickly, and then be able to go off and running using it accurately. So with this form factor, soldiers can pick it up, play with it for a few minutes, figure out what button does what, and they are off and operating the system very, very quickly. The product on the right is a computer soldier control unit for a soldier system. So it's much smaller. It's a single-hand controller. You can see there's a joystick there. There's a keypad. Where that keypad is, a touchscreen could go. Basically, it's providing a single wearable interface that could be placed on a vest or shoulder, taken off and used, and that's the soldier's interface to the systems that he's using. So the intent of that one would be to be on every soldier, provide situational awareness. So what I didn't include, I just realized, is a tablet-style control. So I'm sure most people are aware of the various types of tablets that are out there, and there are ruggedized tablets as well. What MSI's core competency is integrating the human-machine interface, the HMI, the switches, the joysticks, the triggers, and ruggedized at that into more traditional types of controls like a tablet. So what we do is we increase usability and increase accessibility to critical missions and critical operations by providing those types of interfaces in addition to a touchscreen, for example. Next slide. So to give you some context for what we're looking for, I wanted to include for you the types of things that are driving technology development in defense today. And practically speaking, those are mostly reductions in size, weight, and power. If you focus on the picture down in the left-hand corner, if you're involved in defense at all, I guarantee you've probably seen this picture. It shows the physical burden that's on the soldiers today because of all the various things they need to carry. And probably the heaviest thing they need to carry is water. And then they're also carrying a lot of batteries in addition to their weapons, their food, their munitions, and you see all the headgear on there. A lot of that is some heads-up display, flip-down viewers, and various things. But we're asking our soldiers to carry and do an awful lot of things while they're out there and engaging in their missions. So anything that we can do that reduces that load, both physical and cognitive, is going to offer incremental improvements to them. Ideally, you want to strip that all down to a single system that they can access basically anything they need to access, and just let them carry the things that they need for survival, like their food and water and weapons. So I mentioned cognitive load a couple minutes ago, and if you're aware at all of what's going on with technology development and defense, everything is concentrated, not everything, but a lot of things are concentrated on situational awareness and ISR, intelligence, surveillance, and reconnaissance. And so all the UAVs that we've got out there, Predator UAVs that are flying around, Global Hawks, UGVs, unattended sensors, they're all out there collecting data. And all that data is being sent back to various levels of command. And that data is growing on an exponential basis. Filtering through that data and getting to what's relevant and meaningful and actionable is a huge challenge. So data analytics is a huge area of development and concentration right now for defense. But ultimately, that has to be distilled down so that the soldier can filter through to what's relevant to them. Because right now they're getting that cognitive burden that they're getting bombarded with too much information. So they have to whittle it down and get to what they need to act on. So that picture on the right-hand side is basically what's being done today. As systems are being developed and systems are being implemented on platforms, they're being slapped on. So what you see is a whole bunch of individual systems there in a vehicle, and they're not integrated, they're not consolidated. The soldier can't really switch between one another on a single screen. They have to look in different areas. And what this does, too, is it adds power consumption, it takes up space, it adds weight, and it adds a lot of cognitive burden on the soldier to be looking in different places. So what we're looking at doing is removing a lot of that burden, both physical and cognitive. And those are some of the drivers for what we're talking about here today. Next slide, please. So just under a year ago, Secretary of Defense and President Obama came on and talked about changes that were going to be happening within the Department of Defense. They were associated with some cuts and reductions, but ultimately the Department of Defense is catching up with where most of us has already been, which is we have to do more with less. Everybody is asked to be more efficient, do more work, produce more benefit, add more value, and doing that with less resources in terms of other people than we've done before. And what that basically means is that we need better systems to assist us. So the Department of Defense is focused on investing in those systems that are going to provide us the ability to multitask in defense to the extent that most of us do on a daily basis. And so what that means, too, is that we're empowering lower levels of command. And so the decision-making with regards to a mission is being pushed down to the soldier and the commander at the tactical edge. And that tactical edge, what that means is the last mile of engagement. So the people that are on the front lines, because of the conditions of urban warfare and unconventional warfare, they're having to react a lot more quickly. So there's no time to send information back to a command center and wait for orders. These folks have to have the data and they have to be able to act and react accordingly on the spot. And so that level of leadership is being pushed down as far down the chain of command as it can go. Which is why there's that requirement for the time-to sharing and use of that ISR data. So that's part of what's going on. Then, because everybody's being asked to do more, when you've got an operator that's driving a robot and controlling a camera, and they're having to interface with their soldier systems, and they're having to manipulate and use and forward and manage data, they're being asked to do a lot at a single time. And the more you can give them the ability to switch modes in a single system, the better off they'll be able to do that, because they'll know where they are, what they're doing, and how they're doing it. The other thing is that there's multiple system controls. So we've got, right now, a single operator, sometimes two operators, running a single platform. So for example, Predator UAV, you've got one pilot that's flying the UAV and another one that's operating the cameras and the weapon system. Ultimately, what the desire would be is for a single operator to control multiple UAVs or multiple robots, UGVs, unmanned ground vehicles. So again, soldiers are going to be asked to do more and with less people. Next slide, please. Okay. And the less has to do with reducing those loads. So less power consumption, less weight, smaller form factors so we're not adding as much bulk, consolidating those systems that we've been proliferating down to single systems or fewer systems so that an operator can get to where they need in a single place without having to move around or switch between systems physically. You have fewer operators doing more things. And you still have to maintain effectiveness. You still have to accomplish the mission. You still have to provide results. So those expectations are still there. So in the conference that I referred to last year, the key focus was maintain the force, maintain the presence, maintain the ability to respond, but we have to do it with less, which means that we need better technologies to be able to support our ability to respond. We have to be able to deploy and react. Okay. Next slide, please. So now we're going to get into the details of what's being asked for being solicited. Excuse me. So I went through the drivers, so hopefully that gives you some context as to why these requirements and why this technology need is here. So I showed you some pictures of some of the handheld systems that we're working on, and we've got challenges. So we have to make these devices smaller, lighter, they have to consume less power, and they have to support other requirements that are requirements that we're faced because we serve the soldier that's deployed out in Iraq and Afghanistan. They need things like field replaceability. They need standard configurations because things are, every time you have a unique configuration or a unique power supply, it's more for the soldier to carry. So there's proliferation of batteries because there's no commonality between systems, for example. And when we're looking at reducing the size and weight of a handheld device, we're typically at about, for that FMCU, the game style controller with a screen, or for a tablet with those same types of joysticks and switches and triggers designed into them, we're looking right now at about a 3-pound device. And the battery contributes to that significantly. With everything else that we need to pack in there, the battery can even put us over that requirement. So we're looking for power solutions that will allow us to achieve the reductions in size, weight, and power that we need to achieve while still maintaining all the functionality. So we're looking for power supplies that will reduce the size such that it doesn't drive the size and weight of the handheld device that we're working to design and to meet the requirements of our customers. And then those solutions need to have the flexibility to be used on multiple platforms so that they're not unique to just what we design, but they can be used across the board on other soldier systems that, such that they don't have to carry multiple battery supplies. And ideally they should also be rechargeable in a universal charging station that can support multiple battery types. So in terms of what we're looking for with a solution, if you go to the next slide, we're looking to maximize certain things and minimize certain things. So we're looking to maximize continuous operation time, standby time. We're looking to minimize the time to recharge, because sometimes you have to recharge quickly and you need that battery back in. There needs to be hot swappable, so the system needs to be operating while the battery is being recharged. Want things like not requiring a tool to replace a battery. Need to ensure that again that the power supply can be used across different devices, and we need to maintain the flexibility of application in terms of where and how the battery can be placed within a device, because of other component requirements, and other size requirements, or other feature requirements in different products. We might need to locate the battery in different places. So we need the battery to be able to play nice with the rest of the system rather than dictating how the rest of the system is designed. So hopefully that gives you enough. I didn't include detailed specs because I don't want to limit what you might be thinking you need to hit, because we're looking to maximize and minimize. So obviously we want to maximize the power output and improving the current performance of what's available to us. But it's really the size, weight, and power reduction that that we're looking to support here. So that's the drivers and kind of what we're looking for the battery technologies for handheld devices. Here on the next slide. We're also looking for display technologies that can support our handheld devices, because there's challenges there too. A lot of the challenges come from the environment that we have to support, because our devices are fielded in Afghanistan and Iraq, Alaska, and various areas around the globe. So we have to maintain requirements that allow significant fluxes in temperature and extremes in temperature. And we're looking for the systems that we use in our offices. The expectation is that they're going to be bright and readable, and you're not going to have glare. Well, when you take these outside in those environments, the expectation is that you'll be able to control those things too, when current designs and systems don't tend to do that. So we need to be able to, in an outdoor sandy environment, under bright, harsh sunlight, be able to maintain resolution and brightness, decrease glare, maintain sunlight readability, and add flexibility for viewing angles in a restricted space. So, maybe you can customize a screen size on the fly. Basically, the sky's the limit when it comes to this type of requirement, because we're just looking for a display, not necessarily an LCD. There's other types of technologies that are out there, but what we have to work with today are LCDs. And again, we're looking for reductions in size, weight, and power, because they tend to also be drivers for the handheld devices. So we have to accommodate our product design to the LCD requirements with regards to weight, size, and power requirements. And they also tend to be power hogs. And anytime that you add a feature to increase the brightness or improve the sunlight readability, reduce the glare, the power consumption tends to go up. So, looking to level that out so that the stack-ups on the power draw aren't as significant are good considerations to keep in mind. Portability and stowability are big issues, because when soldiers are carrying these types of handheld devices, they usually need them to fit within certain compartments on their fatigues or in their backpacks. So making sure that they don't take up a lot of space, and that ideally they can be stowed, basically put away in a very, very small form factor, then essentially unfolded or unrolled to be used upon demand. A lot of requirements are for touchscreen right now, and touchscreen navigation adds other complexities in a ruggedized outdoor environment. A lot of times our soldiers are wearing gloves, and so we have limitations with regards to choosing inductive and capacitive technologies for touchscreens to support gloved use. And there's trade-offs between being able to achieve what we need to achieve in resolution and brightness when you have to also accommodate gloved use. Significant requirements for heads-up usability. The heads-up displays are important because the soldier needs to maintain situational awareness around him while he's using the display. So what we do know is the ocular displays that flip down in front of a soldier's eye and provide images that way aren't preferred. We know that they don't like them. And they probably don't like them because it splits their normal use of their eyes, and cognitively it's probably difficult to manage. So solutions for heads-up usability are definitely desirable. Scalability, so that it can fit different applications and different sizes. Again, we go from small handheld and a 3.5-inch screen potentially up to a 6.5 standard for a tablet, or even larger in some respects. So ability to scale the solution to different form factors would be very desirable. Tactile feedback or haptics is something that's always looked at. They're out there requirements, but then the implementation becomes an issue. So they tend to get backed off of right now. But if you get a viable, reliable way to integrate tactile feedback on a touchscreen or within a device, that's desirable, especially again with glove use. And I talked about the power management, especially with regards to the stack-ups. So those are pretty much the things that we're looking for. Hopefully it's cleared up some questions for you. But certainly if you have any others, please submit them, and I'll do my best to answer them. But that's most of what I have for today.
Monica, thank you so much. I'm going to open it up now for questions to anyone in the audience. Okay, Monica,
yeah.
For the power output of rechargeable batteries, what wattage level, voltage, and current level are you looking for?
I'll preface this by saying I am not an engineer. I am a marketing person. I do work on product specs, but I did ask for some information from our engineers. So whether this answers the question or not, I'm not entirely sure because I'm not familiar with all of the abbreviations. I don't have anything on the wattage, but, or let me see, yeah, I'm sorry, I don't have anything on the actual power output. I do have something on the charge rate, so that's not answering the question. So I would have to check on that and get back to you.
Okay, it's not a problem. In fact, what I'm going to ask is the person who submitted this question, Monica has her contact information. Give her a call directly, and at that point, I'm sure she'll be able to answer the question for you. She'll have gathered her resources to get the information that you need.
Absolutely.
Thanks, Monica. Any other questions? Okay, I know that there's always a reluctance for folks in the audience to ask questions because you're concerned about proprietary information and you like to keep your information close to the chest. So, Monica, don't be surprised if you have a number of phone calls afterwards. Typically with these type of sessions, people do like to chat one-on-one with the OEM.
Absolutely, and you can always reach me by email. That number there is my direct office line.
Okay, so here's Monica's information, email and phone number. Folks, please feel free to call her with any technical questions that you have. Okay. I'd like to talk a little bit now about the application process. Excuse me. The application is in the RFP. It's out on the Connecticut iHub. And if you haven't been out there yet to register, which you will, by the way, need to do if you want to apply for this program, I encourage you to go out there, register. It's very easy and it's free. Read the RFP, become more familiar with the information that's in there, and then you'll be able to apply. Then you need to form a team. I mentioned earlier that this particular program involves a team of a university or college and a small business. If you are one without the other and you're looking for a partner, please do give me a call. My contact information is at the end of this presentation, and I'll be able to walk you through some things to do. Beginning next week, we're going to have a facility ready for that on the iHub that you'll be able to put your information out there for people who are looking to browse. You'll need to download, complete, and upload the application cover page, not your proposal. This is an important piece, folks, because the iHub has some wonderful features to it, and it does have some very secure areas. Like Facebook, it is a business networking tool. And because it is a networking tool, there are certain things and certain areas of it that will be private and certain areas that will be public. So it's important that the right documents go to the right place because we are concerned with proprietary information and we do want to keep this as secure for you as possible. So once you have uploaded your application cover page, that alerts us that you're ready to begin the process. Wait for a response from us, and we will walk you through what to do next. Now, This is how it will be evaluated. There are going to be a team of judges that's going to take a look at and review your proposal. They will be from the top originators, so someone from Ultra Electronics will be looking at this, and they'll be looking at it with respect to 4 things. Its technical merit. Is it going to do what you say it's going to do? Is it innovative? We'll be looking at the financial leverage to see if you do, in fact, have the money to see this project through. Very often, this is why we ask for companies to be established for at least a year. It takes a while for you to be able to amass the amount of cash that you'll need to see this project through. Now, don't let that be a reason for stopping you. If you think that you might be able to address this challenge but don't have the cash and are looking for an investor, there are several things that you can do. Give me a call. I'll be happy to walk you through that and chat with you about some options. Next thing that folks will be looking at is the market need. What kind of an impact is your project going to have on the need that has been identified? Is it a really good fit, in other words? And finally, we'll be looking at the economic impact. What is this not only going to do for you and your company, but what's it going to do for the economic impact on the state? Is it going to create jobs? Is it going to produce revenue and taxes? State is investing a fair amount of money in this. They want to make sure that there's a return on their investment, just like any good investor would do. And the last thing I want to mention is that the application deadline has been extended. In the RFP, we mentioned that proposals were due by January 24th. Because of the time of the year that this challenge began, we realized that that was difficult for a lot of people to get engaged in and to take a look at and to put together their resources. So we have extended the deadline until the 31st of this month. So January 31st, make sure that you get your proposals in. As far as funding goes, we often get asked questions on who gets the money. The money goes to the small company, and it is the small company who then pays the university or the research institution and pays out their expenses from that sum of money. And finally, we're going to be looking for quarterly reports. So this is not an upfront cash payment. These are payments that will come in increments. Once your proposal is approved, you'll get your first sum of money. After the first quarter, you'll write a report, tell us how you're doing. We'll take a look at the progress. You'll submit your invoices. We'll reimburse you. And then we'll do that each quarter. So it is a quarterly payment and a quarterly reporting type of program. Next steps. I'm going to be getting an email out to you probably by Monday with instructions on how to access the webinar recordings. The slides will be on the recording. I will also make sure that they're out on the Connecticut iHub, and I'll send you an email showing you where and how you can access them there. As I mentioned, if you need help partnering, please let me know. Please do use the Connecticut iHub to collaborate. It's a wonderful tool, but do make sure that you get registered. It's a very easy process, and it will be very helpful for you. Any other questions? Okay. I'm going to encourage you to call all of us. If you have an issue, get in touch with me, Roberta Rossi, and here's my contact information. You can then also call Deb Santee, and please do get in touch with Monica for technical questions, because we really do want to see you succeed, and we're here to get you the best answers that we can and really position you to make sure that you have a good shot at winning these funds. So if there are no other questions, I'm going to close the webinar for this afternoon. Thank you so much, Monica. We really appreciate all the time and effort that you put into this. You've been very helpful. Thank you to the participants. I wish you the very best of luck, and we hope to see some good proposals coming through. Have a great afternoon, everybody. All right.